Hi, I'm Dan Music. In order for a garage door to work and for it to work properly, it must have the correct springs to counterbalance the weight of the door. There are three ways to determine the springs you need. You can weigh the door, or you can provide the manufacturer model number, serial number, and/or PID number. With either of these two methods, you'll also need to provide the garage door width, height, track radius, and drum number. If you don't have this information, and if you know that your garage door worked well with the springs that you had, then you can provide the inside diameter, the wind, the length, and the wire size. In this video, we'll first measure an unwound broken spring, and then we'll measure a wound spring. It's important to realize that we measure an unwound spring differently than we do a wound spring. So in order to measure the springs, first close the door and establish a safe environment. Always wear safety glasses and unplug the power to the opener. Disengage the door from the opener and use a sturdy ladder. Since we're measuring the broken spring first, place your ladder under the broken spring. Step up the ladder and position yourself so you can safely measure the spring. First, determine the inside diameter. Best way to do this is to examine the end cone with a flashlight. Most cones have a manufacturing code on one side, such as M45S or M50W. 180 degrees on the opposite side, you'll find a number designating the inside diameter, such as P200W, designating a 2-inch ID winding cone, or a P175S, which designates the 1 3/4 inch ID stationary cone. These images should help you locate the inside diameters of your springs if you have 1 3/4 inch or 2-inch ID springs. Many of the heavier residential doors use springs with 2 5/8 inch cones and inside diameters. Embossed on these cones will be the numbers like 258 or 2625. If you see on your cones the numbers 1264, 1265, 1266, or 1267, you have Rainer cones for a 2 1/4 inch inside diameter spring. You'll often see Rainer's name on cones and also on the hinges, tracks, drums, or other hardware. On these springs, you'll often find a metal tag that identifies the length and wire size as well, such as 225-22VR. The 225 is the wire size, the 22 is the length in inches, the B designates the 2 1/4 inch ID, and the R designates the right wind. Rainer springs tend to be 2 coils longer, and the inside diameter tends to be 1/16 of an inch narrower than specified on the tags. For example, if you measure 22.5 inches and the tag says 22 inches, order the 22-inch spring. If you can't find any cone markings that designate the inside diameter, then we'll need to measure the inside diameter. We do this as a last resort. The reason is that over time, coils compress and you won't get an accurate reading. Also, when the springs break, sometimes they swell. And you have to be very careful when you measure these springs. Don't try to measure around the shaft. For example, this will increase the 1 3/4 inch ID spring to 2 inches. Instead, rest the inside of the top end coil on top of the shaft and measure the distance between the shaft and the top of the bottom of the coil. Since the outside diameter of most shafts is 1 inch, add this inch to your measurement to arrive at the inside diameter. For example, a 3/4 inch measurement would indicate a 1 3/4 inch ID. If you have an older door, you may have Crawford 1 19/32 inch ID springs. Or you may have old Barcode springs with 1 13/16 inch ID springs. Many of these have 1 1/16 inch shafts with hardware that is incompatible with standard hardware. This ID chart should help you identify the inside diameter of an older spring. Next, determine the wind. There are several ways to do this. The easiest way is to determine the position of the spring on the shaft. Normally, if a spring is mounted on the left side of the center support bracket, it is right wind, and if it is mounted on the right side of the bracket, it's left wind. This applies to doors with spring assemblies where the next object beyond the winding cone is the cable drum, and beyond that, the end bearing. If you have a door where the next object beyond the winding cone is the end bearing, and beyond that is the cable drum, and if the cable comes off the inside of the drum as pictured, the spring winds will be reversed. Another way to determine the wind is to examine the ends. If a spring is turned so the end of the coil is on the top, and if the wire goes to the right, it's a right wind spring. If the wire goes to the left, it's a left wind spring. Turning the spring upside down does not change the wind, and the spring is wound the same way at both ends. Right wind spring cones are usually, but not always, marked with red paint. Left wind springs are usually marked with black paint. A fourth way to check the wind is to use your fist. Curling your right index finger over your right thumb replicates a right wind spring. Curling your left index finger over your left thumb replicates a left wind spring. Third, measure the length. To avoid the common problems we have adding fractions, attach a piece of tape to the tape measure and mark the distance from the farthest end of the spring to the inside of the coil. Next, move your tape and align the earlier mark with the inside coil of this other segment of the spring. Measure to the opposite end of the spring, round to the nearest 1/4 of an inch. Another option is to loosen the set screws of the broken spring and slide the outer segment of spring toward the inner part of the spring. Align the coils and then measure the longest part of the spring to the nearest 1/4 of an inch. Most torsion springs use end cones designed for wire sizes ranging from 177 to 295. Because of this, springs with smaller wire often gap as much as 1/2 inch when the cones are installed. This 1/2 inch difference is not critical to the operation of the door. However, if you see gaps when measuring, we suggest you deduct up to 1/2 inch from the length. Fourth, determine the wire size. The best instrument for determining the wire size is a tape measure. Engineers, machinists, and tool and die makers prefer micrometers and calipers, but these instruments are not as accurate when measuring torsion springs. This is because torsion springs are often rusty, or they're coated with paint. Also, even if the spring wire is clean, it's still curved. Micrometers can measure accurately only the sides of a coil, and these are not normally accessible, except on some of the springs manufactured by Crawford and overhead door where the ends have been straightened. And one problem with calipers is converting 64ths of an inch or 128ths of an inch into thousandths of an inch. In my 30 years in the door industry, I found that the 20 coil measurement is the most precise way to measure springs. You must be extremely accurate and very careful when measuring 20 coils. Cutting a board 1/8 inch too short can be remedied with a little caulk, but if you miss your 20 coil by 1/8 of an inch, your door probably won't work. Before measuring, check the end of your tape measure. The end piece should be perpendicular to the length of the tape. If it is bent, get another tape measure. Also, please note that the clip at the end of the tape measure is slotted the thickness of the end clip to accurately displace the difference in distance when measuring the inside of an object. You push on the clip to measure the inside of an object, and you pull on the tape when measuring the outside of an object. Also, before measuring, you'll need to count and mark 10 and 20 coils. A good way to do this is with 1/2 inch by 1 inch strips of paper. Mark the coils away from the ends of the spring because the coils are often gapped on the cones. Count 10 coils. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And bend the spring until the coils separate enough to insert a piece of paper. Count 10 more coils. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bend the spring and insert the second piece of paper. While our goal is to measure 20 coils, we mark and measure 10 coils and 20 coils to confirm that we counted the coils correctly. It's so easy to miscount the coils. First, measure both sets of 10 coils to assure you counted the coils correctly. If the 20 coil measurement is not twice the 10 coil measurement, recount and remeasure your coils until you locate the cause of the discrepancy. Next, determine the 20 coil measurement. Be sure to pull on the tape. Measure the coils like you would a stack of quarters, from the left side of the first coil to the right side of the 20th coil. Check this dimension against the spring chart and against the following images. Notice also the color code for each wire size. You can't rely on your spring's color code to determine your wire size, but you can usually rely on the color, if present, to confirm your wire size. Pause or back up this video until you find your wire size. 0.187, 0.192, 0.207, 0.218, 0.225, 0.234, 0.243, 0.250, 0.262, 0.273, 0.283, 0.295. If you have 2 springs on your door, record your wire marks at the beginning and after the 5th, 10th, 15th, and 20th coils. These marks will be used to help us safely determine the wire size of your wound spring. There are 2 obsolete wire sizes and several German wire sizes that complicate the wire measurement process. If you get exactly 2 inches on 10 coils and exactly 4 inches on 20 coils, you may have .200 wire. If you suspect you have .200 wire, check every inch mark up to 10 inches. If you have .200 wire, every 5 coils will fall between 2 inch marks, and every inch mark will be centered between 2 coils. If you get exactly 4 3/4 inches when measuring 20 coils, you may have .237 wire. If you get exactly 4 3/4 inches on 20 coils, and not a 1/16 inch less, check the following. First, the end of your tape measure. Is it straight and perpendicular to the tape? Second, are you pulling on the tape when you measure 20 coils? Third, check for gaps between the coils, press them together and remeasure. Fourth, are you measuring between the coils and not on top of the coils? Fifth, recount your coils. Sixth, if you have measured properly and if you still get 4 3/4 inches and not a 1/16 of an inch less, count, mark, and measure an additional 20 coils, or 40 coils total. If you have 237 wire, the 9.5 inch mark will fall dead centered between 2 coils. We normally convert the 200 wire to 207 and the 237 wire to 243. If you have a Horman door with the original torsion spring hardware, we recommend you convert to standard hardware. You will need to weigh your door and provide the track radius along with the width and height of the door. We've now completed measuring an unwound broken spring. Now we'll walk you through how to measure a wound unbroken spring. Never touch a wound spring. You can't safely measure a wound spring like you would an unwound spring. If you have 2 springs on your door, it is now time to measure the wound spring. About 30% of the doors out there have unmatched springs. If you measure both springs the same as one of the unmatched springs, your door probably won't work, or it won't work correctly. As an installer winds the torsion spring, it grows longer and the inside diameter shrinks. The wire size, the thickness of each coil, however, remains the same. It doesn't change. First, check the inside diameter of the spring by checking the numbers embossed on the cones. Don't assume that both springs have the same inside diameter. Second, determine the wind. The wound spring should be the opposite wind as the broken spring. Confirm this as we showed on the broken spring. Third, measure the length. This wound spring has grown the length of 1 coil for every turn of tension on it. To account for this extra length, we deduct the first 8 coils from the length on a 7-foot high door. Keep your fingers and hands away from the spring. Keep your tape at least 1 inch away from the spring. Align the end of your tape between the 8th and 9th coils from one end and measure to the other end of the spring. Try to measure within the nearest coil. Generally, an error of up to ½ an inch does not make a noticeable difference in the performance of the door. On 8-foot high doors, measure from between the 9th and 10th coils from one end to the other. If the lengths of your springs differ by more than 1 inch, you want to pay special attention when measuring the wire size, because the wire sizes are probably different as well. Fourth, determine the wire size. Check the 5, 10, 15, and 20 coil dimensions recorded earlier against the coils of the wound spring. If all 5 marks line up between 2 coils, the wire is the same. If at least one does not line up with the coils, you probably have unmatched wire sizes. If so, you will need to measure 10 and 20 coils as before, but keeping your hands and fingers away from the coils. For safety, follow this procedure. Mark a starting point on a folded piece of paper. Hold the paper next to the spring. Count and mark 10 coils about 1 inch from the spring. Move the paper away from the spring and remark the paper closer to the edge of the paper. Check the new mark against the line between the coils and mark a longer line as needed. Repeat this process as needed. Count 10 more coils and mark in the same way as before. Refine the mark as before until you have a precise 20 coil measurement. Measure the 10 and 20 coil marks with a ruler and check these measurements against the chart. Confirm the 10 and 20 coil measurements by marking the dimensions on the edge of a piece of paper and counting to see if the marks match the 10 and 20 coil lines. One final note, we suggest you check your springs against the common lengths chart to make sure that your springs fall within the normal dimensions. This will help assure that you get the correct springs. I'm Dan Music. I hope you found this video helpful. Thank you for watching.